Today I have the pleasure of introducing another young academic in our lecture series, who is, like last time, incidentally a Schneider as well. We met Philipp at the poster session of the PhD last spring, and his project spiked our curiosity regarding his background as well. Philipp has a background that is still quite rare, but becoming more common recently. Like our own Johanna Styriko, he studied computer science as well as history, making him a valuable asset early on as a student assistant and later on as a research assistant in many different projects. The skills showcased just by his CV ranged from the conceptualization of databases to social network analysis, knowledge graphs, and data literacy. His participation in projects includes Quadriga and the NFT for Memories, amongst others, as well as his current employment at the chair of digital history in Berlin, where you can actually study digital history as a specialization within the History Masters program. Today, he is going to talk to us about his PhD project, which is what caught my attention in the first place. It's about images, namely medieval coats of arms in context, which he is researching with semantic web technologies. This topic combines many of our interests, so it is a real treat, and we are looking forward to our lecture.
Yeah, thank you very much for having me and for the very kind introduction. So, and of course, thank you for the opportunity to present my work here in this context. The basis for the talk, as you said, is my PhD project, which is called Codes of Arms in Context, the aggregation and analysis of heraldic data on wall and ceiling paintings in French and German-speaking areas with semantic web technologies.
You have 5 minutes plus if you need to slow down.
Okay, just the title is, but I will try. Please remind me again if I start to speed up. Okay, so the historical or historiographic research goals of this project are mainly or the question how are interior spaces used for visual communication with coats of arms in France and the Holy Roman Empire, and to study to what extent murals, so painted walls and painted ceilings, murals and manuscripts form a common space of visual communication. So the overall historiographic goal is, so to speak, to do a distant viewing analysis of visual communication with collection of coat of arms in interior spaces and manuscripts. Of course, this begs the questions: why do we study coats of arms as a historical source? So coats of arms, as you can see, were very common in the European Middle Ages and early modern times. We have a huge variety of objects which could carry coats of arms, and that was because heraldry or coats of arms were a very powerful and versatile tool for visual communication. This was used by almost all classes, so there were, of course, knights and nobles who used them, but we also have peasants who used coats of arms, for example. And a single coat of arms could communicate a variety of things like ownership of something or dominion or claims to dominion, jurisdiction, group affiliation, honor, kinship. The exact meaning of a single coat of arms is very dependent on the specific historical context of use, the historical context of use and the material context of use, of course. So one coat of arms does not always mean the same thing, so to speak. All this put together does make a coat of arms an important historical source for visual communication in this instance. So I don't study heraldry not solely from an auxiliary scientific perspective, like historische Grundwissenschaften, historische Hilfswissenschaften, but as a source in its own right from a perspective of cultural history. What are my methods to study this? So I do a lot of ontology engineering to create machine-readable descriptions of coats of arms, to contextualize coats of arms in their historical material sources. Other things like the placement of coats of arms in three-dimensional interior spaces. I do linked open data, data-driven analyses with knowledge graphs. So to specify the main goal of the overall PhD project, not only the historiographic goals, are to research digital methods with a large focus on knowledge graphs and data-driven analyses in historical studies. So this is what I understand as my main contribution, so to speak. And a main challenge of this project is that there is quite a rapid development in many areas, especially semantic web technologies, now also LLMs, of course. And that's why fairly recently I restructured my PhD into a cumulative project. I have to write 4 papers So one paper on ontology engineering, one paper which is a more general approach on modeling, where I study how we can transfer analog description systems of visual sources into digital models. So from a theoretical perspective, there's a paper on auxiliary science and ontology engineering, and lastly, historical case study where I want to research the imperial quaternions and also evaluate data-driven methods, how we can use knowledge graphs for historical research. So these are all at different stages, so to speak. Today I will mainly focus on the first one, but which is finished. So this is finished, and this is almost finished, so to speak. So this is, and of course, branching in the other parts of the project as well, but this will be our main focus for today. And just a little bit of context for my PhD project, because this was also embedded in a project funded by the Volkswagen Foundation, for which I worked firstly when I got to Berlin. So my PhD project and this project is not always easily separable. So there are also some overlap in my talk between the PhD and this project. This is why I give you this as a context. I'll just glance over that. So we had a few historical research questions on how, when and where heraldic communication changed over time, for example, and a methodological strand where we wanted to study how we can use AI-based methods for historical research at the with the example of heraldic sources. AI-based methods, I wouldn't use this term anymore because this is from the early 2020s with a much broader meaning encompassing symbolic and AI and sub-symbolic AI with knowledge graphs and machine learning. And now, of course, the term is a bit more, unusable, so to speak. Okay, now to get to the point, what are the challenges of studying heraldic sources in general, not just with digital methods? We have a huge quantity of sources. So in the Middle Ages alone, there are estimations that we have over 1 million different coats of arms. So 1 million different pictures, not 1 million instances where a coat of arms is placed. So huge quantity. We have a heterogeneity and disparity of sources and repositories, because the sources that carry coats of arms are stored in archives and libraries and museums. We have indirect sources, so to speak, or documents for monument conservation, which describe these sources. Heraldry in itself is a bit complex because it has complex rules. It has a special language to describe coats of arms. It is multilingual. And yeah, all of this does, of course, make a need for digital approaches. A central problem with this, or central challenge, is how can we represent single coats of arms as data? There are already a few heraldic databases from the past, such as, for example, the Ordinary of Medieval Armorials by Sten Clemenson. Sten Clemenson is basically a citizen scientist and heraldist who created this huge database with over 80,000 coats of arms during his retirement, and this is something we can use. This database works by storing coats of arms in natural language. So classically, from a historical auxiliary science perspective, we can describe coats of arms in natural language. This is called blason, or blazon in English. For example, we have in English, for this coat of arms, we have the description azure fleur-de-lis, or, so gold, accompanied by a bent girl charged with 3 lines argent. So you already see this is a special language, so you have to know some of the terms, and then it's fairly obvious what is displayed. In the database, this looks like this. So it's also a string that is stored, but a string that is a bit more semi-structured. This is already helpful because we have a huge database which does this, but it has also a few disadvantages to actually study heraldry. For example, we can only work in English, of course, because the database is in English. It's still an expert system. We have to know these database-specific abbreviations and conventions. relationships between the objects are fairly complex. The searching for things is only possible with exact terms. I can search for line or lines, but I can't search, for example, for animals or birds or dragons. Yeah, which for flowers as well. Even small typos lead to completely different blazons. So when there are mistakes or errors in the data, I don't get the results. And yeah, due to all this, I cannot really use this to draw general conclusions about the development of the use of heraldry and coats of arms. So this is why we built an ontology to model the data. First of all, maybe since you're digital humanities students, who of you knows what an ontology is, or even has used something or built something like this before? You don't have to raise your hand if this term is completely new to you. Okay, perfect.
They should know.
Okay, then don't look back, please. So, I have a section to explain what an ontology is, but so what is an ontology? This is a rather old but still very good definition. An ontology is an explicit formal specification of a shared conceptualization. The term is borrowed from philosophy, where an ontology is a systematic account of existence. And for AI systems, again, AI pre-2023, for AI systems, what exists, it is what can be represented as data, of course. So conceptualization means it's an abstract model with concepts and relationships. It's explicit, it's formal, it's machine understandable, and it's shared. So there's a consensus in a scholarly community, for example, on what the terms means, what the terms mean. And this works with RDF, with the research description framework. So we can describe knowledge in this triple structure with subject, predicate, object. Like, for example, we have an entry in the database which stands for a coat of arms, and we have a property that's, I should have translated that, sorry, which has a property like has an attributed entity that uses this coat of arms, and then we get an entity which is Pont la Marche, like this. It's important to note that everything in an ontology, in a semantic object database, is an URI. Is an URI, or is represented by an URI. So this, and this, these are all unambiguous and clearly defined URLs over the web. So I have, so to speak, in a clear and unambiguous ID for everything in my database and every term I use in my database. We can build a class structure. So everything we model has a semantic meaning. The semantic meaning that is also machine readable, which we can use, for example, to pose more general questions. Like in this instance, we have a specific coat of arms which is attributed to a specific entity. And I could also ask, using this structure, okay, give me all coats of arms that are attributed to this specific entity. Because one person or territory or something else could carry multiple coats of arms, and I couldn't pose these questions to the database in this way. This is the representation in the machine readable form. I don't go into that. An important distinction is we have, when we put this together, a terminological layer and an assertional layer. So to speak, the model and the data, all this put together is called a knowledge graph. And this part, the data model, so to speak, is called an ontology in this context. Just to familiarize us with the terms used in this context. Okay. The question is, of course, how can we create such an ontology? This is, of course, relevant for your own studies as well, if you want to do such a thing. So modeling in general is, from my point of view at least, more or less like a core of how we work as historians, or maybe how we work as humanists. This is a step where we use our domain knowledge to conceptualize the things we want to study, and to say, okay, these aspects, these specific assets, this is what we want to make representable as data, and this is what we can study afterwards with data-driven methods. So it's a fairly complex process. The question is, how can we deal with this kind of complexity, where we translate, so to speak, the real world into data metal, and how do we make this this process of translation comparable from a research perspective and also traceable for our researchers. And this is why there are methodologies for this. So these are just a selection of existing methodologies or methods of ontology engineering from computer science, which are, so to speak, instruction manuals, what steps we have to follow to build an ontology. In our project, or in my PhD, we're focusing on modular ontology engineering, which I will show you in a minute how this looks like, but we focus on modularization. So we have something which, or knowledge graph that is created. No, I will show you in a minute. Sorry, got ahead of myself at that point. I will skip that. An important step of creating an ontology, and an important step in all these methods I showed you, is to create competency questions. Competency questions are basically research questions that your ontology, that your data model is supposed to be able to answer. So I create a selection of questions which I want to do, for which I want to do my research, and my ontology works, so to speak, if it's able to, or if I'm able to answer questions with my ontology, with my model. For example, I can ask which persons or other entities used a specific combination of coats of arms in other sources, on other source contexts. Like, for example, this one in the middle here. Okay, then I want to get a result like this. I also want to get this seal, which shows which depicts the same coat of arms, which in this instance has another attributed entity. So this is the coat of arms in this context of Philipp the Good, and this is of how's it in English, Charles the Bold. So different entities, but the same picture or image. I also want to get this, or want to be able to get this with this research question. It's again the same image, but I don't know if you see this from the back, but there's also it's called a band, like a red line that crosses over the whole coat of arms. Which is an indication in this instance that it's the coat of arms of Antoine de Combatard. So yet another person, but the important thing to note is that I want to have this ambiguity, that it should not, or it does not have to be the exact image, but there should be some way of modeling different parts of the coats of arms as well. Another question would be in which this doesn't make sense. So the question is, I want to look for coats of arms that also use these 3 golden lilies, and I want to get this. In this instance, the 3 golden lilies, or fleur de lis, for the non-medievalists, this is a clear attribution that someone has close proximity to the French royal house in some case. So this is basically a page from a manuscript showing different lines of the royal of the King of France, or sidelines. So I want to be able to search for single charges. I also want to pose questions like, what is the geographical distribution of some heraldic figures, where I can do analysis like this, and I say, okay, this label or label has a more low countries English distribution. These are the places where maybe births were used as heraldic images, something like this. I also want to pose questions like, okay, I have a sequence of coat of arms, like this sequence around, and find other instances where this sequence can be found as well. I will not get into the historiographic details at this moment, but we can discuss this if you like afterwards. Okay, so I have my competency question, my research questions, which the ontology should be able to answer. I can use this to extract so-called key notions, so aspects that the ontology has to model to be able to answer these questions. These are these ones. So I have to model persons, entities, combinations of coats of arms, source context, and so on. And this is where we realized that we actually need 4 ontologies. We need one ontology for heraldry as a system for describing coats of arms, one called representation, which describe the concrete material instance of individual coats of arms, object for basically the metadata for the sources, and entity, the people, territories, abstract ideas that could be represented by coats of arms. Or from a different angle, in a more conceptual overview, we have objects like manuscripts. This manuscript has metadata, and it is composed of different object parts, like in this instance a folio or a page, which has coats of arms, and I can attribute this coat of arms in this specific instance to a person in this case, and I can describe this coat of arms with the rules of Blason. So I can describe which heraldic elements I use to build this coat of arms. So we have therefore an ontology describing the objects, the representation context, so the concrete material context, heraldry, and the entity which carries the coat of arms. And the same thing works for other objects as well, of course. So in this case, I have a mural which has paneling at the ceiling, which shows coat of arms, and yeah, and so on. Description and the attribution to a specific entity. Okay, I will go a bit deeper on the heraldry ontology now. So the ontology to actually describe or blazon specific coat of arms. To do that, I have to say a few words about how heraldry actually works. Because when we hear heraldry or coat of arms, we of course think of images like this. But actually, a coat of arms could also be represented as text, as blazon, so this historic specific language to describe something like this. But from a historical point of view, this is the same. So the important thing to note is that a coat of arms is not a visual image, not necessarily at least a visual image, but a conceptual image that is built from these heraldic these heraldic parts. Also, these heraldic parts, these are independent from their concrete visual representation. So all of these represent heraldic lines. As you can see, this is quite a different style. It's also from quite different eras and epochs. But from a heraldic perspective, it's the same thing. It's always a line. It's the same concept. And this is what we can make use of when we build an ontology for heraldry. So we just have to break down all heraldic concepts. So identify on a very granular level all the terms that are used to describe coats of arms and transfer them into classes. So we get an ontology with 1,300 classes and 99 properties. We have to structure this, of course, because what we don't want to have is just a vocabulary or thesaurus which lists heraldic terms. In this instance, we would say, okay, we have a coat of arms which has 3 red fleur-de-lis. But if we stop at that, these and these are the same. So we have to build in some kind of structure how a coat of arms is built of different heraldic elements. So we have so these are basically the superclasses in the ontology on the left side, and then we have charges. So things that can be depicted, charges and patterns, so things that can be depicted on a coat of arms. But we also have heraldic or terms borrowed from heraldry that describe, for example, the arrangement of things on a shield, like a dorst or impale. The terms are not important, but it's important to note that you have a specific term to describe how these objects are arranged on a shield. You can have different styles for things. You can have modifiers, like when a lion is, or an animal module is drowned, or different attitudes of animals, if they stand or lie down and so on. And this is actually relevant, again, from a historical perspective, because coats of arms change, and you often have instances where, for example, some lower noblemen or even person without a noble title, how do you say sozialer Aufstieg? Does some social mobility, sorry, rises in society, and this is often connected with changing the coat of arms to visually communicate that you are advancing in society. And this is something where you can say, okay, I have an animal, let's give the animal a crown. So it's relevant to identify this point where in the sources the coat of arms change in such a minor way, just as a side note. Okay, what we also have is a phenomenological class structure. For example, so one use case for the ontology is you are an archivist or a person working in a museum and you want to identify a coat of arms. Identifying meaning you have this coat of arms in a source and you want to know who used this in which other instances. Okay, but how would you search for this? You would of course say, okay, you would search for fish, but from a classical heraldic perspective, this is a barbel, so it's a specific kind of fish, which is not evident from the image, but only from the context. So what we did was to create a class structure for the charges, so that you can say salmons, barbel, trouts, and eels are all fish, even if they maybe not the eel, but the other one basically look the same in coats of arms, and this is how we deal with that. What we also did was to implement multilingualism. I said before that heraldry is multilingual because it was an European-wide phenomenon. The class names are in English, but as I said before, the class names are heraldic concepts, not heraldic terms. So we used, I think, 6 different heraldic manuals to import definitions and translations for all the terms or for the heraldic concepts, so that you can use it in French, German, and English. Just to give you an example how this works more concretely, we have, for example, this coat of arms, which we want to describe. The structure of the ontology works in a way that it's divided into a field which has metadata like its pattern and its color, its tincture. It has heraldic object charges put on top of that, and other objects, and on top of that are other objects as well. This just as a conceptual overview. In RDF, this looks like this. I will not go into detail, but if you're interested in the actual structure, how this works, we can go. I would propose into that during the discussion. Another layer is the representation ontology, so the material and visual context of coats of arms. There we have, for example, one challenge that we have conflicting blazonings, conflicting descriptions of the same instance of a coat of arms. So we have this instance in a manuscript, and we have this line. This is supposed to be a line on top of this red band, and we can describe this line as passant or rampant, which are different attitudes. So if it's I can't remember the German terms, because the German terms are very different from the English and French ones, but it's the attitude, how it's standing up or lying down, basically. And we can differ on that. And the ontology deals with that by creating some layer in between called a description act. So we separate an entity which describes the instance of the coat of arms in the material context in this particular manuscript. And the heraldic description, of course, this is another entity with another URI. And in between, we have another layer, which is called a description, which basically says, okay, person 1, person 2, at this instance, use this description for this coat of arms. So we don't say, okay, this coat of arms has this description, but it's clear who did at what point this interpretation, and it is made explicit in the data that it is an interpretation. The same goes for attributing coats of arms to people, territories, other entities. So in this way, we implement multi-perspectivity. of course, this is also something which we have in historical studies in general when we deal with sources. So from a historical point of view, we separate normally between the description of the source and the interpretation of the source. And this idea that these are two separate things, this is something we wanted to incorporate into the ontology, because we are building an ontology for historians or for historical studies. So this ontology, this data model, should also incorporate our methodological and theoretical assumptions about our discipline and about how we work with our material. If this makes sense. Okay, this is just the current status from the ontology perspective. As I said before, we have this database with, or rather almost 90,000 different heraldic representations taken from 286 manuscripts. This was transformed with the ontology into RDF, so this is reusable. Another aspect is intermediality. So we have different material carrier objects for the same coat of arms, like ceiling paintings, manuscripts, seals, the textual blazon, and so on. And this is built in such a way that they have an image layer using IIIF that is connected to a layer of representation, which is connected to the description of the coat of arms, which is then connected to the entity which carries the coat of arms. So this is basically a summary of what I just said, just to give you a more general overview of this architecture. But of course, another question is, of course, now how do we get the images into this knowledge graph? So we are now leaving the conceptual ontology level, but working with actual scans and images from the sources. There we followed three different approaches. Firstly, detection, so machine learning detection, which is basically a model that is able to identify the places in an image collection where coat of arms are placed and creates these bounding boxes. We also did some experiments with segmentation. This is in very early stages, where we want to have a machine learning model that actually detects the single elements on a coat of arms. And we also did some experiments with similarity-based approach, which also follows the goal of identifying what is on a coat of arms, which heraldic charges, heraldic elements are on a coat of arms. And the idea is, of course, basically, okay, we group together what's similar, what looks like a line, and from that we can make a connection with the ontology and, so to speak, describe a system that automatically describes, automatically bases or describes coats of arms. The most advanced one is the detection model. So we started with this in 2019 with a precision of about 80%, and now with it's not even the current YOLO model YOLO framework. We have a model with an accuracy of 99%. So just to give you an idea of the advancement in the advancements in the last few years. This is what I explained before. I'll skip over that. Segmentation again means we don't have just the bounding box, but also actually the exact pixel contours of each element. And this is more difficult to train and to create training data for that. So this is where we created, I think I have to start the video manually. This is where I created a tool in collaboration with a chair for computer science and a small company. Basically a tool to create training data for a segmentation algorithm. And this is using SUM, so segment anything model from Meta, which is a transformer model, not a large language model, but a transformer model. And this is quite helpful because, as you can see, this is zero shot. You have this model in the background, and you just click on something, and it automatically recognizes. Not recognizes it in a semantic way, but recognizes its boundaries. And the tool works in a way that you can have a backend with the machine learning model, but also you can implement you can upload an ontology into this tool. Like, so this is the heraldry ontology, and you can use this to say, okay, this specific heraldic element is defined as a cross in the sense of what the heraldry ontology understands as a cross, if this makes sense. Okay, but this is very early stages. The tool is finished and it just has to be published. But this is not something which I'm currently working on. Just as a Okay, so just again as a summarized overview, this is the simplified architecture of the whole knowledge graph of the whole project. So we have images on which runs a machine learning detection, which identifies the bounding boxes. The bounding boxes are stored via IIIF into the knowledge graph, which also contains the description of the coats of arms, the heraldic descriptions, and data on the historical context, like, for example, data on the entities that carry coats of arms and on the objects, like the manuscripts. And okay, I've got to do a little shout out on all the students' assistants which helped to connect all this. I normally explain this a little bit more what they did in the talks, but I didn't want to delete this slide just to make the works of students' assistants visible, who are also part of the project. So, the last layer of the project is an RSA part, so research software engineering part, where we created a web app which you can use to work with everything I've described before. This is just a web-based online application which is based on Research Space. Research Space is a framework originally from the British Museum, where you can simply build web apps to work with knowledge graphs. And what it enables is mostly faceted search and data entry to edit things in a knowledge graph. As I said, you can edit data using the ontology, also using the structure of the ontology, and you can use this faceted search, which I'll just show you shortly. So the use case again is you have this coat of arms in this instance on a mural in a castle, and you don't even know what the figure of this on this coat of arms means. I don't know if someone knows already. Please raise your hands, but I wouldn't know. So you can use the structure of the. Oops, sorry. You can use the structure of the ontology. No, I have to restart it again. Oh, I'm so sorry for being clumsy. So, okay. So the idea is you use the structure of the whole ontology, because in this instance you don't know what the heraldic figure, the heraldic charge is called, but you know that these maybe are two and they are arranged in a specific way. So you can search for things that are arranged in this particular way. Okay, and then you get all the coats of arms that have things arranged in this particular way. You can also specify, because it's a faceted search, the color and so on. And then you get an idea that in other instances, this coat of arms is used for the family Lichtenburg or for the city of Beethoven. That's the idea of a use case. This is, of course, not something I work with in my PhD, because I focus more on data-driven methods. But this is something we can offer historians or archivists, museum experts who have to work with sources that carry coats of arms, but who are not experts in heraldry and have no intention of becoming one, which is understandable. Of course, you can also use Sparkle to query the knowledge graph, which is what I mostly do. Okay, so I was way quicker than I intended to be. I hope I didn't talk too quickly. But this is again the summarized overview of the whole architecture of the knowledge graph, which now also has this entry point, so to speak, where you can either use the data with Sparkle or you can use it with a web app. This is the current state of things. The next phase is now that we have successfully acquired funding for a new project, which is called Heraldic Identity in Context. This is in collaboration with the Chaire d'Informatique Occidentale in Paris. And the goals of this new project for 3 years are mainly to research visual communication of identities of groups and individuals in France and the Holy Roman Empire, but also to extend this knowledge graph with seals, because now we have mainly a focus on manuscripts. I work on murals, but of course you can do more with this if you have a huge, greater diversity of objects and object types. And yeah, of course, finalize all the software prototypes that it's more usable and more widely available. The start of the project will be September 2025, so this September. And I'm telling you this because we have 2 small positions at the Humboldt University for this. For once, research software engineer and knowledge engineer who works with semantic web technologies, and secondly, a PhD student who should do the historical research with the data, which can be a more old-fashioned analog way, but which can also focus on digital methods more. But the idea is this person should do a PhD on the historiographic research questions. So if you are interested in this or in the 3 other positions we have currently advertised, just follow this QR code, and yeah, with a pleasure to work with you. But for now, I hope I wasn't too quick. I'm finished, so thank you very much for your attention, and I'm looking forward to your questions.